What is the largest empty place in the universe? You might think of interstellar space, a vacuum so empty that light takes 4 years to traverse it. Or perhaps the barren moons of Mars, 500 million miles away from the Sun. But those are mere pinpricks of emptiness compared to the true champion of vacancy, the Boötes Void, a cosmic desert nearly 330 million light years wide. To put that into perspective, it would take 10,000 years to fly from one end to the other, even at the speed of light. Today, we'll journey into this great nothing. First, we'll uncover how it was discovered. Then we'll see why it challenges everything we know about cosmology and what it might reveal about the true nature of reality. Let's jump in. We humans tend to think of ourselves as special. After all, we're the ones asking the questions. But out there among the 100 billion Earth-like planets in the Milky Way, there could be countless civilizations just as advanced as ours, maybe even more so. And if that's true, there's a good chance some of them have been watching us for quite some time. One of the most extraordinary things about the Boötes Void is just how ordinary it seems. The reason for that is a bit complicated, so bear with me. Most objects in space aren't floating in isolation. They're part of a massive network known as the cosmic web. Billions of galaxies are linked like threads, weaving together clusters, filaments, and walls. And between these glowing threads lie dark gaps known as cosmic voids, regions with far fewer galaxies. Most voids are pretty small, spanning around 30 to 50 million light years. That's a lot of space. But on a cosmic scale, it's relatively speaking pretty tiny. Now, it's worth noting that the discovery of the cosmic web was something of a surprise. Early astronomers who looked up at the night sky believed galaxies were evenly distributed throughout the universe. But by the 1970s, surveys showed that galaxies were gathered in clusters. By the late 1980s, the picture became clear. Galaxies formed a vast network linked by filamentary structures. And then came the voids. And so, in 1981, when astronomer Robert Kirshner and his team at Harvard Smithsonian began mapping galaxies in the constellation Boötes, they expected to see something like this: a few small holes in an otherwise fairly even distribution. But when their survey, known as the CFA Redshift Survey, was completed, it revealed something truly remarkable: a gaping hole in the map, an enormous blank region where galaxies should have been. But before we continue, let me tell you about today's sponsor, Brilliant. They sponsor this video because they believe in the importance of practical STEM education, which is why they offer courses in math, science, and engineering that help you learn by doing. Their interactive lessons grow your skills incrementally, building confidence along the way. Start with one of their signature courses, like algebra or solar energy, and you'll be well on your way towards a deeper understanding of our world. Or check out my favorite course, Scientific Thinking. It'll teach you how to apply the scientific method to everyday problems. So whether you're interested in becoming a professional engineer or just want to expand your body of knowledge, Brilliant can help you get there. The first 200 of you will get 20% off Brilliant's annual premium subscription. Back to the Boötes Void. At first, many astronomers dismissed it as a mistake. Maybe the data was corrupted, or the galaxies just hadn't been mapped yet. But as more observations confirmed the gap, it became clear that they had stumbled upon one of the largest known structures in the cosmos. By 2003, the Sloan Digital Sky Survey had charted more than 100,000 galaxies in the void. By 2018, that number exceeded 500,000. And yet, considering its sheer size, the number of galaxies within it remains paltry. For comparison, there are about 10 trillion stars in the Milky Way, and the vast majority of those are packed into a thin pancake just a few hundred light years thick. That means over 99.9% of the Milky Way's stars reside within a sphere with a 100,000 light year radius. Now, compare that to the Boötes Void. Even though it's 3,300 times larger, it contains less than one part in 100,000 of the Milky Way's galaxies. Inside this great nothing, there should be billions of galaxies, according to statistical expectation. Numbers can't fully capture just how staggering the Boötes Void is. Our Milky Way measures just 100,000 light years across. Imagine lining up over 3,000 Milky Ways side by side, and you'd still barely cover its diameter. To put it another way, if a beam of light left one edge of the void, traveling at 300,000 kilometers per second, it would take 330 million years to reach the other side. For comparison, the distance between Earth and the Andromeda Galaxy, our nearest large neighbor, is only 2.5 million light years. The Boötes Void is over 100 times that span. So what caused it? Conventional cosmology explains smaller voids as natural outcomes of matter flowing toward denser regions after the Big Bang. Galaxies migrate, pulled by gravity, leaving behind underdense bubbles. But the Boötes Void is too large to fit comfortably into these simulations. One idea suggests it wasn't a single void at all, but a chain of smaller voids that merged over billions of years, creating a supervoid. Another theory proposes gravitational tug-of-war. Nearby galaxy clusters may have siphoned away galaxies, deepening the emptiness. But if you want to hear something really crazy, some astronomers speculate that the void is filled with dark matter and dark energy structures of a kind we simply cannot yet perceive. Dark matter and dark energy are two of the most mysterious phenomena in the universe. Together, they account for roughly 95% of the universe's mass and energy, yet we've never detected either directly. Dark matter is thought to be a type of matter that doesn't interact with baryonic matter, the stuff that makes up stars, planets, and people. Meanwhile, dark energy is a hypothetical form of energy that's even more elusive. For decades, astronomers observed that distant galaxies were moving away from us faster than expected. They hypothesized that this unexpected acceleration was driven by a repulsive force, which they dubbed dark energy. Dark energy could explain why the universe appears to be accelerating in its expansion, but it also creates a problem. If dark energy exists, it implies that the universe has a uniform energy density everywhere. But the Boötes Void is so empty that it shouldn't exist if dark energy is uniform. Some researchers hypothesize that the void isn't just a hole in space, but a hole in dark energy. Maybe dark energy is patchy, and the void lies in a particularly dark region. Others propose that the void is a relic of cosmic inflation, those split seconds after the Big Bang when space itself expanded faster than light. If inflation wasn't perfectly uniform, it could have left behind scars, immense regions with suppressed matter. There's even a mind-bending theory that ties the void to the possibility of a multiverse. Imagine multiple universes, each with different physical laws, colliding like soap bubbles. The Boötes Void might be the aftermath of such a collision, a place where another universe pressed against ours, erasing galaxies in its path. So why do we care so much about a giant patch of nothing? It turns out that the answer could change everything. The sheer scale of the Boötes Void has led to new instruments and techniques to observe it. Scientists are refining measurements of dark energy, the mysterious force accelerating cosmic expansion. They're also looking deeper and deeper into the void to see if anything interesting pops out. In 2022, researchers announced the discovery of a huge cluster of galaxies lurking at the edge of the void. Known as the Megazircus, it's one of the largest known structures in the universe. It's 1.3 billion light years across and weighs 30 trillion times the mass of the Milky Way. The discovery of such a massive structure, so close to the void, provided new insights into how matter and energy distribute themselves across the cosmos. The Boötes Void is not just a silent, gigantic experiment set up by the universe itself, but also a reminder of how much we don't know. It challenges the boundaries of our current cosmological models and pushes us to develop new ways of thinking about the universe. As we peer deeper into its inky blackness, we might find the answers to some of the biggest mysteries of our existence. Or we might find something that defies our understanding entirely, a glimpse into a reality that's stranger than we ever dared imagine. Either way, the journey promises to be an exhilarating ride into the heart of the unknown. So, what do you think? Is the great nothing just an accident or the signature of something far bigger? And are there even more voids out there that we haven't discovered yet? Let me know in the comments below. And if you enjoyed this video, please make sure to subscribe. Your support means the world to me. Thanks for watching. See you next time.